Okay, morning everyone.
Yeah, good morning. And so I'm here with, I'm Don Murray, and I'm here with Stuart.
Yep.
And this is, I guess, part two.
Yeah.
Of we had a high-level overview of all about APIs, building them, more consuming them in that one.
Yeah, connecting to them. Yeah.
Yeah, and this one, Stuart is going to show us how to build an API. He's going to build it on the fly, and aside from some Lambda code to get around a weakness in API gateway, which I'm sure they will ultimately fix.
Yeah.
Basically, there's no code. So, and this code we're just going to give away because it's just just a little bit. But you can ignore that and just remember that that's just to get around a problem in Lambda. Now, for anybody who didn't see the first webinar, of course, we are happy if you stay. But this is really going to be a really technical webinar. On how to use, really focusing on Amazon API Gateway. So we just want to be very clear about that right from the start.
Yeah. Exactly,
so people aren't.
It'll be me doing a demo for the most part and showing you how to configure things, but it will be recorded. So you maybe just watch it, and then afterwards you can get the video, get the GitHub link, go through the example, follow the instructions. So that's kind of the idea.
Okay.
It should give you a good flavor for how it works and how to do things.
Yeah, it's really exciting. We're seeing more and more of these all the time. These frameworks that enable us to build APIs, very, very quickly. So before something like Amazon API Gateway, what would I have to do to build a nice REST API?
You would have had to write your own code, probably a nice web framework like Node or Rails or Java, something like this, and then you would have had to deploy it. You would have had to manage it. You would have had to manage the infrastructure. You'd have had to manage the security. You'd have had to manage the rate limiting and everything.
Load balancing. I'd have to do all with that.
Yeah, so there's a lot to do.
Okay.
And that's really why we haven't talked about it in the past.
Yeah.
Because obviously we have an excellent connection on top of the data, but building the API was really, you needed a good set of developers to do that.
Yeah.
And now even I can figure it out. So,
yeah.
It's things are changing fast.
No, that's great. That's great. So all these resources are going to be put in GitHub, or they'll be at the bottom?
Yeah, we'll link to the GitHub repo at the end, and there'll be a video sent out, and the link to the GitHub repository will be in that email as well.
Okay, great.
So I think we can get started
it's
now.
all looking great.
So
I think people know what we do at SAFE. We essentially build data pipe, and that is getting data from wherever it is to where you need it, and all kinds of data. Yep. So in this one, you might say, well, how does this one fit into that theme?
Yep.
Well, in this case, we're going to have data in a database, and we're going to use our technology FME with API Gateway to bring this data to an API framework. So now you can easily get at it with any application that talks to this REST API.
Exactly.
So a great way, in an organization, you might have silos of information. By putting using API Gateway or another technology like it with FME, now you can easily, dissolve these silos so applications can easily work with all of them.
Exactly, and this is legacy, it's web applications, database, file-based, we do it all, right?
Yeah. So, good.
So, why should you care about creating APIs? The last webinar was all about consuming them, bulk loading into APIs, synchronizing APIs, but why should you care about creating your own APIs on top of your data? This is really what we're tackling in this webinar. And the key point here is the first one, really, and it's about providing a stable, clear interface to your data and business processes. So imagine if you're a large engineering firm and you have a big project coming up, multidisciplinary project. You could just provide your database out to everyone. A SQL connection, there you go, connect to my data, but that's a poor interface. It's not developer friendly. You're giving direct access to the database, so you're lacking control. You won't know who's doing what. So the API on top of that database gives you stability. It gives you clarity, and it's easy to use.
Yeah, it also, if somebody gives me access to their database as a developer, now I have to understand, they might have hundreds of tables.
Exactly.
I have to go in and try to understand all those different tables, and I might just get to the point if I want to do something quickly where I go, you know what, the benefit just isn't worth this effort.
Yeah.
Whereas you, who understand the database, you could talk to me and say, well, what do you need? Now with something like API Gateway, you can very quickly build me a REST API. I can use it. I'm separated from the database.
Exactly.
And if you change your database, all you need to do is make sure that my REST API calls are still supported. So
yeah.
it really, I really like the second point you make on that slide, which is, decoupling the data from the business logic. I think that is a huge win, and it just makes it easier for everybody.
Yeah, and if all your data's in PostGIS and you want to migrate to Oracle,
yeah.
if you're using an API, no problem. You can switch it out without the user knowing anything. So that it's a big deal. And so if you're putting out websites, just think, can I put out a web service as well?
Yeah.
And I think the third point is, if you have all of your data in a really old database and you want to make it available to developers or the public, you don't need to necessarily do a big migration to a new database. You could just put an API on top of that legacy system.
Yeah.
So modernize your old legacy applications using APIs as well.
Yeah.
Is key.
Yeah. No, that's great.
So the evolution of the API, this is kind of, why have we suddenly started talking about this? We mentioned this in the last webinar, but it used to be the self-hosted API, and this was the early guys building their own APIs in PHP or whatever, Rails, Play, Node. They wrote the code, they designed the interface, they wrote the doc. These are the pioneers. Then we moved to the managed API, where you still wrote all the code, but these services cropped up where they were kind of like a proxy. So all of your traffic went through these services, and they did the doc, they did the scaling, they did the security, and they did the rate limiting, all that kind of stuff. So that's kind of the management tier they took care of, but you still had to write your own code. You still had to write your own business logic. And now we're shifting into the third phase, which is the serverless and codeless. So here in this scenario, you can still use the API management. API Gateway has a few tools, but really you can design the GUI for the API in API Gateway, or you could use Azure API management. We're not tied to API Gateway. We're just showing this as an example in this one.
Yeah.
And then the business logic, sure, you can still write code, but you could also use FME to define your business logic in a GUI.
Right.
And that's what we're going to do today.
Okay.
So you can see it's kind of separating everything out into these microservices.
Yeah.
And that's a pattern we've seen as well.
Yeah.
So when is this codeless API a good fit? When does it work to think about using this model instead of rolling your own? Firstly, if you don't have any developers, you're kind of stuck, right? You're not going to build an API with no developers, so that's the first phase. If you're a small shop, you want to do something quickly, this is great. Agility, if you want to create an API quickly. So, deploying your own code, the infrastructure, that all takes time. This you can do something in a few hours. Once you get going with API Gateway, so if you want to try something, maybe we call them disposable APIs for the lifetime of a short project, this is a great fit as well.
And how about maintenance? Because I know as a developer, I am one, you are one, we love to write new code.
Right.
But how excited are we as developers to have to maintain old code?
Yeah, code debt sucks, right?
Absolutely.
It gets bigger and more painful the larger you get.
Yeah, and just looking at the work you've done here, I came in after and I looked at it, and with the API Gateway, it's very clear to see where the code is for the posts, where the calls are.
Exactly. Yeah.
And as far as if I give this to another developer or another person that uses this, I'm convinced that the ramp-up time for them is going to be much quicker.
Right.
Yeah.
And there's this separation as well. Someone could build the API in API Gateway, and the person building the workspaces can have nothing to do with it. Well, not nothing, but it's a completely different skill base, and that separation is key.
Yeah.
So when is it not a good fit? If you're building Twilio or a massive API with millions of requests a second, you need to hyper-optimize. This is not a good fit.
Yeah, so if you have a really small, like if you have to have a response within 10 milliseconds, then, then you need to be...
And you need to scale across many nodes, and you need to be in different data centers for resilience. This is for the small to medium-sized project,
Yeah.
but it is for production workflows. I think that's key. It's not just for prototyping.
Yeah. Yeah. No, that's good.
So let's get stuck in. This is when we start to dive into the actual creation of the API and look at API gateway. So we have a PostGIS table here.
Okay.
Simple stuff. We call it a transit API. All it really is in this scenario is a buses table.
Right.
So we're tracking the location of buses in Vancouver. We have a bus ID, a route number, a timestamp, a bearing, north, south, east, west, a speed, and then the geom, the location. So very, very simple stuff. We want to turn this PostGIS database table into a full API.
Okay, and we're going to call this API the transit API.
We call it transit
Sure.
API. You know, if there's a request and if this has a lot of interest, we could expand the scope of this. This is a nice, simple example. So what we want to do, we want to create buses, we want to update buses, we want to get all of the buses. So kind of the CRUD operations on top of this table. Nice and simple.
Okay.
So
what do you mean by CRUD?
Create, update, and delete.
Okay.
It's kind of a web API term, more of a developer term, but it's just basically putting a kind of layer on top to do operations on top of the data. And it goes back to your point, it's controlled. So we're controlling what they can do against the database. In this example, actually, I don't want to allow delete. So we're not going to expose delete, just create and update.
That's another benefit of when we were talking about the benefits of an API over a database that I missed.
Right.
And that's also you restrict people from doing bad things. Because I could, if you give me access to your database, I could inadvertently, truncate a table, But now, that's a great point.
So this is a very high-level overview of the architecture. So we have API gateway. Again, this could be Azure API management, or there's a few other tools out there as well. Here's where you're going to design and manage your API.
Right.
And this is where you're going to do all the security, the scaling, all the dashboards around the usage. But really, it's where you're going to define the resources. You're going to define the get, the post, the put. You're going to define the HTTP statuses. You're going to define whether you want to accept query string parameters or headers. And this is where I'm already starting to get a little bit more technical here, but it's the design component of the API. Then we have this Lambda section. So Lambda is Amazon's compute service. So all this is, think of this as just a way to run code without any infrastructure.
Right.
So I thought I could get away with doing this demo without doing this, and I could just call FME Cloud directly from the API. But what Lambda gives us in this little bit of code is much nicer error handling.
Right.
So I wanted to do it properly. This is kind of a hack. It's a limitation of API gateway and the way it handles error responses.
Right.
The thing to know is, yes, there is some code, but you're going to be able to just copy it, use it, and you won't have to do anything.
Okay. And you did some reading on the API gateway forums, and this thing you're solving here with Lambda is a well-known and discussed limitation of API gateway.
Exactly, and I'm sure they'll fix it in time.
But absolutely.
Anyway, for now, it is code, so the title, you might think the title's a bit misleading, but you don't have to write in it, you can just use it. And then we have FME Cloud. So FME Cloud is the data access and business logic which sits on top of the data.
Right.
And in this case, we're using PostGIS.
Now I could do this on top of I could use FME Cloud just to be clear. That's the FME server that we are hosting.
Right.
I could use the same stack with FME server on premise as long as obviously the REST API gateway would have to be able to see the server.
It just needs to be a publicly accessible endpoint.
Okay.
An API gateway can't currently be deployed within VPCs.
Okay.
But we know it's coming. People are quite animated about it on the forums.
Absolutely.
Okay, so now let's just dive in and do, what I want to do is talk about an existing request that I've already created and walk you from the front, from the dock all the way to the back and then back to the front again.
Okay.
And then we're going to create an API call after that. So let's just go in here. So this is what the final API documentation looks like. So I haven't written any code here. This was produced by Amazon. It's called Swagger. It's a big open source project. And you can see it's quite nice API documentation. It's fully documented. They've got the status codes. It's interactive,
so you can
so I can
try
actually try the API out within the browser. It gives me the curl request, the request URL, the body. So it's nice.
It's really nice.
So what we're going to do is just walk through this put request. So this put request allows me to enter a bus ID. So I'm going to paste my bus ID in, a new latitude and a new longitude. So I can paste those in. And then a route number. So the first thing we'll do is I just want to make you aware of the kind of the error handling that we've put in place, and we're going to talk about that in a second. So I'm going to enter an invalid bus ID here, and we'll see what happens. So if you see here, we've got a nice message with a response here telling me that the invalid attribute, the bus ID, does not match. The status code is correct.
Yes.
So this is, you don't get this if you just connect to the data directly. It's a nicer interface. So if I enter the correct bus ID, the data is successfully updated. Another one, if I enter invalid latitude, I've got invalid coordinates. Look how fast it is as well. It's milliseconds.
Milliseconds,
So this is, the latitude measurement should range from -90. It's helping me out. So let's see how we do that.
So to be clear, just to jump ahead a little bit, every time you say try it out, that's going all the way from API gateway to running an FME server, and then coming all the way back.
Correct. Yeah, good point. It's a full working API. So let's dive into API gateway now and see what's actually happening. So we have this put request here. So this is the API gateway interface, just to kind of talk you through it. You can create as many APIs as you want. You can see on the left here in the navigation, this is where you define your resources. So /buses, and then nested under buses, I have buses /bus ID. So I have a post to do a create, a get to get all of the buses, and then a put to update the bus.
Right.
So when you click on a resource, the panel on the right changes here. And it's relatively logical once you get your head around it. But imagine the request is coming in here on the left. So the first thing we need to do is define the method request.
Right.
So this is, what do you want to expose to the end user? What do you want the API to look like? Do you want there to be query string parameters? So yes, I have latitude, longitude, and route number. Do you want there to be request headers? I don't need any here, but you could set authorization stuff, tokens, request paths. So this is the /. If we look here in the transit API, this is this part here. This is a request path. It's the bus ID is in the title. So we definitely need that, and that's a request path parameter.
Okay.
So I'm defining this endpoint here in API gateway. So then what I need to do is, the request comes in and people have set these values. What I need to do then is get the data that's coming in into a nice structure to pass back to FME Cloud. So this is where this integration request comes in. So you can see here it's saying, okay, this API gateway is really a proxy. So it's saying, where do you want to send the request to? Do you want to send it to a Lambda function, another HTTP endpoint, or just stub it? With a mock integration. So we could go directly to FME Cloud here. As I said, we're going to Lambda for the error handling gains.
So more for the return code, not so much the
calling. Not the calling. So let's have a look down here. And what we're doing in this part here is essentially taking everything that's coming in from the API, the request being made, and turning it into JSON. So let me scroll down a bit here. This is the templating language Amazon give you, which may look really confusing. The nice thing is they give you a method request path to use. You can just click that and it just generates all this for you. And all this is doing is it's taking all the parameters, the query string parameters, the headers, the body, and it's turning it into JSON. That's all it's doing. And I've actually added my own here as well. You can customize this. So I've added in a workspace. And the workspace is the FME component that we're going to run when this API gateway gets called. So I could have just made one massive workspace and put everything in that and called that, but I thought it was better to split things up. Okay, so now the request gets forwarded to Lambda, and so this is the code on Lambda. All I really want you to be aware of with this Lambda function, you can look at it in GitHub later. this is what is responsible for making the HTTP request to FME Cloud. So we're building up the query string here with the FME Cloud URL, the path, and then we're making the request. And then I'm doing all of the error handling in here, and we're sending it back to API Gateway. So that's all I'm going to talk about for now on that.
Okay.
So now let's dive into the workspace. So this is what's running when they make that API call.
Okay.
So transit API update bus. So this is a nice thing. Everything's in a GUI. Let me just zoom out a little bit. It's not massively complicated.
No.
The first thing we're doing is error handling. So we're going to let the user, essentially what they do is they pass the values into this workspace.
Yeah.
Just like query string parameters into an API call.
Yeah. Yeah.
Are the coordinates valid?
Yes.
Are they in this range?
Yeah.
Yes or no?
Yeah.
If they're not, let's create the JSON here, the error message, and cancel things.
Right, and this is the part that API Gateway couldn't parse. There was no way to pass back the status that you wanted.
Right, yeah, exactly. So this is why we've done the Lambda thing. So because we wanted to give you that nice error handling, because I think that's the cornerstone of a good API.
Right.
It is good error handling.
Yeah, yeah. Now, from a unit testing perspective, as I'm developing this, I could just test this workspace completely independent of everything else.
Exactly, yes. Yeah. That separation is really great because you could have someone that just understands this, building your workflows, and then they give them to someone else to do the API Gateway side.
Right. And I can test the Lambda part as well.
Yeah, you can test the Lambda part as well. It's a little bit more tricky. That's evolving.
Okay.
But you can use Lambda to do that. But then you start getting a little bit more production ready. But if there's demand, we can talk about things like that in further sessions. So then we're going to check for a valid bus ID, a valid route number, and we're just checking to see if this power of FME, it's all obvious.
Yeah.
Is the route number attribute, is it an empty string?
Yeah.
Then we're going to get a little bit more fancy. We're going to go out to the database and we're just going to see if the ID exists. Because if the ID doesn't exist, then we really want to send this error message, which says invalid attribute, the bus ID does not exist.
Yeah.
It's an error. The next thing we're going to do is create our geometry. Obviously, a lat long was passed in, an XY, but we need to turn that into a real geometry for PostGIS.
Right.
We're writing to PostGIS. So this is a nice thing as well that we do down here, at the bottom here in this panel. We're calculating the actual bearing here, so the north, south, east, west of the bus. And this is where FME comes in as well with the business logic side of things. What I have is I have my new point, and I have my old point in the database.
Yeah.
So what I'm doing here is going out with the feature reader, which goes out to the PostGIS database and retrieves the existing point. And then I'm doing a from-to builder. And I'm building a line from the old point to the new point. That's all it does. And then this azimuth calculator, if that's how you pronounce it.
Yeah, azimuth calculator, perfect.
Is going to calculate the angle of the line.
Okay.
So it gives us the angle of the line, and these are off the FME hub. I haven't written anything here. These came off the FME hub. And then you can see this transformer here. This does range mapping. So it says if the angles between this were in north, northeast, east. So
clever. Yeah.
So that's you could of course write that in code, but it wouldn't be this simple. I guarantee you
exactly.
And then we write the data out to the PostGIS database with an update, and if the data was successfully updated, we return this message.
Yeah.
So again, we could return the data here. We could return a link to documentation. We have complete control. Okay. So now let's go back to API Gateway. The requests come in. The response is coming back from FME Cloud to Lambda, and Lambda's then forwarded that request to this API Gateway interface. Here we're down in this arrow down here.
Yes.
So now what we need to do is define what the endpoint looks like for the response.
Right.
So these are my response codes.
Yep.
And let's map them here. 201, 400, 500, and 200. So that's what this is. We're creating our doc essentially here. So, if there's a 200, a 201, you can map. We need to set the access control origin. We'll talk about that later. But what we need to do now is map the incoming JSON that comes back from FME Cloud to these response codes.
Right.
So hopefully I'm not losing everyone here.
No, because you said it. So basically, an error happened in FME. Let's say we got, and the status. You made a nice JSON message that said the status was. So all we want to do is take the 400 from that status and map it to the HTTP code. And that's the part where you really needed the Lambda.
Right. Yeah. If you just leave this and don't do this, then this 400 status will go to the 200 response code. Yeah. I see. So if we go in the integration response here, you'll see we have this it's this regex that's looking for status 201 and mapping to that response status. For 400, this is saying anything that starts with a 4 come to this response status.
Yeah.
So people have already created these. You can mostly just copy these.
Sure.
This one here is basically a catch-all.
Yeah.
For internal server errors that API gateway throws.
Right.
So that's a front-to-back kind of overview of what it looks like when a request comes in and goes out. Now what we're going to do, if we go back, please ask some questions if you have any, and we can tackle those at the end. We are going to have some time at the end. What we're going to do now is add a get bus request. So if we looked in the API currently, we can get all of the buses. We can create a bus and we can update a bus, but I want to just be able to add one bus. So let's do that now. That's what we're going to work through. So the first thing I need to do is add a get request. So this is the resource I want to add a get request on. So I'm going to add actions, create method, and this is going to be a get request. Check that. Okay, so now I have my get request, and it's saying what integration type do you want? Well, we want to hit this Lambda function, which is in US East, and it's called Transit API Resource Handler. So I'm going to save that. This is saying, okay, we've got to give API permission to execute that function. Okay. And it sets up this interface. So now what we can do is logically go through this interface and just basically update every box.
Okay.
So first thing we need to do is look at method request. What do we want to expose to the end user for this call? Well, the only thing we actually really need to expose is just the bus ID and the path, because we don't really need any query string parameters. We're not updating anything.
No.
And Amazon actually does this for us. If you use curly braces when you create the resource name here, it knows it's a path
query. Okay.
Query, and sets it for us.
Yeah. Okay.
If we wanted to add query strings here, we could. No problem. The same with request headers.
Yeah.
A request model is if you're doing a post.
Okay.
So if you're doing a post and you're going to post JSON, and you want the documentation to basically show what the post looks like.
Right.
I'm using query strings here, but if you're posting JSON, it would say, hey, the JSON needs to look like this.
Yes.
So that's purely for documentation. Really.
Okay. Okay.
Okay, so now we've defined the bus ID. What we need to do now is set the integration request up. So we're going to the Lambda function, but we need to do this request body pass-through. We need to basically turn these request items into JSON for Lambda. So I'm going to add a mapping template of type application/JSON. Save that. Okay, yes, we'll secure this integration. This is just saying, do you want to lock it down to this content type? I do, that's fine. And I'm going to generate a template here. So don't get too worried about this templating language. Amazon generates it for you, and then I find you can just delete things. So you can see all this stuff here, it's passing in. If you're doing authorization, this is where everything gets set in the JSON here as well.
I see.
So what I actually need to do is set another little value as well, which is the workspace I want to run. Because the Lambda function is going to read this in, and it's going to run whatever workspace I set here.
Yes.
So I'm going to save that. You also have to be careful in the API gateway. There's a lot of save buttons everywhere, so I think I've got that. Okay, so what we need to look at now is how's this workspace going to work? So I've got another workspace here, which is the GetBus workspace. I've already created it.
Very simple.
Very simple, but very easy to understand. So the first thing we're doing is the same as the last one. Out to the SQL executor, only takes a few milliseconds. And I'm doing a count start, basically.
Sure.
How many bus IDs exist? Test to see if the bus ID exists. If the bus ID doesn't exist, we've got a problem. We need to trigger this error message and send it back to API Gateway.
Yeah.
If it does exist, we're going to use the feature reader, which is just reads the data from PostGIS, and we're passing in this where clause using the ID that was set in API Gateway.
Right.
So we go out there, then we use a geometry extractor to turn the geometry object that comes out of PostGIS into well-known text, which is, I guess it's a nice way to represent a point, right?
Yeah. Yeah.
We could do, this is the nice thing about FME, it has all of these other options. If you wanted to do a GeoJSON or a GeoHash, you just click the button.
How do you want it? Yeah.
Exactly. And then we're going to create our JSON. And this time the JSON's not just an error message, it's the actual JSON with the data in it that we're building up here.
Right. Yeah. Good. Simple.
So now, should we publish it up to cloud?
Yep.
Okay, I don't think, okay, so let's go up here to cloud. So this is my FME cloud instance.
Wow, good name.
Yeah, it's my my Google ID. Signed up with my Google login. So here is, I've created a repository called webinar. You can use whatever you want. And I'm publishing, I've already got it up there, but we're going to overwrite it. No reason why it shouldn't work. This is new for 2016. Do you want to upload the web connection with that? I don't actually need to do it. It's already up there.
Okay. And that's to the PostGIS database.
To the PostGIS database, which is running on RDS, Amazon RDS service. I'm going to publish that up there, and that's it. So let's go have a look now. Let's tie together that Lambda calling FME and what that looks like. So we're going to go into, this is FME server, the instance running on the cloud. And you can see here, if I update this home page, we're going to see in my latest uploads here, my last published workspace is getBus1. So what this has done, this publishing, is it's turned that GUI workflow into an HTTP endpoint. So this is where we used to end the story and we'd say, hey, run everything through here, this is how you do it.
Yeah.
So you can see here, I can set a bus ID here, and I can run the workspace. And so when I run this, this should return the JSON to me.
Yeah.
So that's really all we're doing with API Gateway is basically running this query string here.
Yeah.
This URL, sorry, with the query on the end. This bus ID, see?
Yeah.
Okay, so that's going to be now run. So if we go back to API Gateway now, let's actually just do a quick test. Let's see what this looks like, because this kind of helped me understand the next workflow.
Okay.
So let's go test here, paste this in here, and test that. So that actually kind of worked.
Okay.
We've got a status code 200, and you can see the JSON here is wrapped in this error message handling, which is the weird thing with API Gateway. Basically, you can't trigger a success and have control over it. So you have to do a fail and then to do regex against it. That's the discussion on all the forums.
I see. Oh, wow. Yeah.
So note here, if I put an incorrect bus ID in and click test, the other problem we've got is the JSON's coming back okay, but we've got a 200 response code, which is no good.
Yes.
I want a 400 response code.
Yeah.
So let's go back to fix that. The first thing we need to do is go to method response and add in the HTTP statuses we want to expose. So I'm going to expose a 400, and I'm also going to expose a 500 as well.
Yeah.
500 is good for kind of a catch-all.
Sure.
It means an internal server error. A 400 error means it looked okay, but the input was bad. So we could add 404 in here. We could add a whole bunch of things. 201. The other thing we need to do now is we need to define a response model.
Right.
Because, like, if you look here on the documentation, under get buses, the doc is telling the user what the response is going to look like, which is really important. They need to know what the response is going to look like. So I'm going to add a response model in here. Actually, no, I don't. I just need to update this one. And it's a get bus output model.
Okay.
Get that right. So let's have a look at that. What does that look like? And really what this is doing is it's writing doc. That's really all this is doing. It's not really doing anything else. It's just ensuring Swagger can create the doc. And it uses JSON schema. So, you know, I've defined the properties here, type string, type number. I could add more in here. I could add description. Sure. If I wanted a much better documented API, I could really go to town on these model schemas.
Yeah.
And remember, you can have these on the input as well. Okay, so I've added my response codes. I've set my model. Now what we need to do is map the JSON that's coming in to these response codes. So we need to set some lambda regex here that's going to basically find the 400 code here in this JSON. That's what we're looking for. That's the unique thing about this JSON, this 400 code. So this looks like this. Pretty simple, really. You can. There's a lot of these out there. I mean, it's just regex, so you can find that. Click save, and so now this 400 state is going to be picked up. So if I go back here now and enter an invalid
bus ID.
Yeah, bus ID. Thanks. You can see the status is correct now.
Yeah,
it's 400. But the error message is still wrapped in this weird tag.
Yeah.
So let's fix that. This is, you know, it seems really complicated, and it is a little bit. But once you learn it, it's you get quite fast.
Yeah.
Why I'm telling you this stuff is these little things like this took me ages to figure out.
Yeah.
So I just want to make you aware of, you know, all the little things that you need to do to get this end-to-end working. Here, this is all we need to do. We just need to paste this template language. I think it's actually jQuery that's saying just find the error message attribute in the JSON.
Yeah.
So I'm going to save that, and again I have to save up here, and we're going to do that on 200 as well. Okay. So this is looking good. Let's go back to test the API. This is a nice thing. You can test things here. So now my JSON looks good.
Yep.
And is that a D on the end? And my response looks good. So that's good. Everything looks like it's working.
Yeah.
So let's deploy this. Let's create the doc.
Okay.
And let's deploy this. The first thing I've got to do though is enable CORS. CORS, our lovely friend. What CORS is if you see here in the API this URL, this is pointing to an Amazon endpoint.
Yeah.
You can put this behind a vanity URL, by the way, if you want. But I'm calling it from localhost. All turning CORS on enables you to do is call this URL from another host.
Okay.
It's a browser restriction.
So basically, it tells you that other server is trusted, essentially.
Exactly. Yeah. So Amazon does this for you. You go actions, enable CORS, and I'm going to enable on these methods. Enable CORS. Yes. And it uses the options header here. I think you can actually hide it in the doc, but I haven't done that.
Yeah.
And then what we need to do is just go through, because it adds the header request onto the 200, but for some lovely reason it doesn't add it on the 400 or the 500.
Okay.
So you have to add that in there.
That's interesting.
There's a few little,
Yeah.
But it does work. It's just, you know.
Yeah.
Some gotchas.
Yeah.
And then you also have to come in here, and if you look on this 200 here under heading mappings, you can see that the header's been set, but you actually have to set a mapping value in here.
Okay.
Don't worry if you don't understand this. All you're going to need to do is kind of follow it along
in the
recording. Or the great thing is about this is I'm going to show you in a minute. We're now going to export this, and this JSON file that it creates, you can use to create all of this, set it all up. So now what we're going to do is deploy this API, and this is really where the power of API Gateway comes in. You know, you've designed it, you don't have to worry about the infrastructure, but they also have deployment stages, so you can create a production, staging, development, you can deploy, you can test. I'm going to deploy this. And now this is saying, okay, you've deployed this. Do you want to enable an API cache? Do you want to enable in-depth logging and monitoring? So you can set alerts up if you get 500, things like this. Rate limiting, burst limiting. You can generate SDK documentation for Android, iOS, JavaScript. The crucial thing is you can export it here. So I'm going to export this as a Swagger documentation. You can also export it as Swagger with API Gateway, which is, you need to do that if you want to import the JSON into API. This is just for creating the docs.
The doc, yeah.
And Postman's great if you don't want to host anything. Postman's a Chrome extension.
Okay.
And you load the file into this Chrome extension and boom, it fills everything out.
Oh, wow.
So that's the quickest win. So let's download this JSON. And so what I'm just going to go do now quickly, because this is, you know, we're doing a real demo here kind of thing. So I'm going to go get this. So this is one I just downloaded at 8:39. We're going to update my the JSON in here. Let's call this one old. And let's update this guy. So I'm just replacing the Swagger doc just to show you how easy it is, and I'm not writing any doc myself. So there is 5 calls here at the moment. We should see an extra one pop in. Yeah, we've got 6. There it is.
Perfect.
So get the bus ID.
There it all is.
And I'm just going to copy the bus ID again. And so if I enter an invalid bus ID, we should get the 400 response here with the error. And yes, it's a nice response code.
Yep.
And if I enter the correct one, then yes, I will get the correct JSON return. So that's it. That's the end-to-end workflow.
Yeah.
What I just want to go back and quickly show you is kind of talk about latency a bit.
Right.
So if I go here on the GET request and make the request, see we've got a latency there of 500 milliseconds.
Yeah.
FME does keep the connection open, so if you have a lot of requests coming in, you can see they're about a third of a second. And remember, we're going out, we're doing a whole bunch of things in that workspace. That's pretty fast.
We're hitting the database twice, for example.
Yeah. So our Rails stack with hosting FME Cloud and like our coded APIs that we provide, we get about 100, 150 around there. So you do have a little bit of overhead, but unless you're like, it goes back to millions of users, then you're good. I mean, that was my good. I was kind of pleased.
That's amazing. That's amazing.
So that's a lot of information. Hopefully, kind of was helpful.
And really, people watching, it's really to just watch, and understand what can be done. The videos there to walk through step by step.
Yes, exactly.
Yeah. So we have time for some. Do you have anything else you want to go through? Questions?
No, I think that's enough. I mean, again, there is an Azure one, and you could use that. Amazon API Gateway is maturing, but I would say it's production ready. The stability is there. It's more the kind of interface is a little bit fiddly.
Okay, so we have some questions here. So from Siggy, we have what happens when FME Cloud is down? So basically, the server on the back end is down. Right. API Gateway can you define timeouts or things like that?
Yeah. So this is where that Lambda function comes in as well. If API Gateway, if FME Cloud is down, then Lambda will get a 404. You can handle that error and propagate that back as a 404. It gives you that control.
Yeah, that's great. And you are going to publish somebody asked about what GitHub project for the API test app.
Yeah, so it's here. I mean, you can write it down. If you just go to Save Software's GitHub repo, it's in there, it's public. I'm going to update it today just to add some really in-depth instructions on, because what you can do, as I said, is you can go here in API Gateway and you can actually import an API, and you can select a Swagger file, and it's going to create this API for you. So that's pretty powerful.
Yeah, that really is.
It actually means you can build your API in Swagger if you want, because Swagger have a design tool.
And then just import it.
Just import it,
That's great. That's great. So somebody asked, Dr. Priyanka asked, is Lambda mandatory?
Right, so let's go back here to look at that. So if we look at that GET request here, an integration request, I could just hit FME Cloud directly in there. It would work.
Yes.
But I would have to send, everything would go back to the 200 response status.
Yeah.
The only way I can force an error is to basically do a force a failure on the FME Cloud side.
Right. And in fact, to do what you did, you forced a failure. You returned error every time.
Yes.
To the Lambda function, and then the Lambda function, because that's the only way to get information back that then you could, ideally, you would be able to send something back from FME server and have the API gateway do the regexp on that raw return.
Exactly.
And then you wouldn't have to do that.
So,
so the answer is no, it's not mandatory, but by using Lambda, you were able to create a much better REST-like experience as far as return codes.
Yeah, and this Lambda function, the idea is I will actually optimize it a bit today, but you can, I was scared of touching it before the webinar. I was like, I can improve this last night. I was like, no.
Yeah.
But you can, you're just going to paste it in, point to it, and then use it for every call.
Yeah. Okay. So if there's a bus ID, then it will give an error. Okay, somebody asked, so if I give an invalid bus ID, then it will also give an error on, yes, because that would be, you would get the
That's a good point, Siggy. Yeah, so it's, even if it was a valid bus ID, but yeah, what you'd probably have to do is update the
yeah, you would look for status equals probably rather than just the number.
I think I actually, if we look on you just need to do a bit fancier.
Yeah, you're right, Siggy. If you had 400, because we looked for a 400, but really
so here we go.
Yeah, Stuart is showing now the more complete version of it there. Yeah, and that one isn't going to fail because it had to have status in front. So that's good. Yeah. How long does it take to run the workspace from desktop? Same as 200. No, if you run in desktop, it'll actually take longer. The reason is on desktop, the engine is not already up and running, and so it takes like Stuart can run it, but it's going to take longer.
I've got debugging turned on as well, right?
Yeah, which will slow it down a little bit, but then the whole FME workspace has to come up on server and cloud. The FME engines are already loaded, so they're just waiting for the job. So remember that 280 isn't just the FME cloud. It's got to go through API gateway. API gateway is a proxy. Then it passes it to Lambda. Lambda is another proxy. Then it passes it to FME server and comes all the way back. And each one of those layers is not free.
Exactly. Yeah.
So.
Yeah, maybe. Oh, okay. Robin's chatted out the GitHub link there as well.
Okay. Perfect. Yeah. So. Can you keep the workspace loaded between calls? The answer is yes, you could. So if you had a really high speed, then you would have to your workspace flow would be a little bit trickier. But you could do that.
There's another way you could do it as well, to do really high speed via SQS probably.
Yeah.
Because we can poll from SQS.
Yes.
So you could use Lambda to send jobs to SQS. But just talk to us if you want to do anything more impressive. There are ways, but I had to keep it as simple as possible.
Yeah. So the answer is yes, you can do things to, but of course, extra complexity.
Yeah, exactly.
If you have a workspace, another good question from Siggy, if you have a workspace that takes 2 to 3 minutes, will the API wait?
Yes, but Lambda has a timeout that you can set.
Okay.
So you'd have to set that higher.
Yeah.
But it should wait. Yeah.
Yeah.
I maybe wouldn't necessarily recommend that. Maybe it should be.
Trigger and then you could maybe pass in a callback or something. Anyway, there's other architectures, but yeah. Good question. Okay, that's been done. The GitHub link was just chatted out for folks to see. Are there indicators of, say, the cost per API call? Okay.
Yeah. So what's that? The fourth question. So API gateway is $3.50 per million API calls. So pretty affordable. And the data transfer costs out of API gateway are 9 cents
for the first 10
for the first per gigabyte for the first 10 terabytes.
Okay, so pretty cheap.
Yeah.
Crazy cheap.
And then FME Cloud you'd have running.
Yeah, and you're paying not paying extra for any of this. It's just part of it built in.
And FME Cloud is, someone's asking, you look at the website, but to run one all the time, unless you're doing massive load, it's probably about $4,000 a year.
Yeah.
And that gives you the instance as well, all the hardware, the software, everything included for that.
Would it run at the same speed if you've got thousands of requests per second?
Yeah, I mean, we've not tested that. Maybe I should test it. In theory, yes, because you can scale FME Cloud.
Yeah.
And so obviously API gateway scales.
Yeah.
FME Cloud, we can have as many engines as you want. But you just have to scale your architecture at each tier. The database might have to be a little bit bigger than the smallest one to handle the load.
Exactly.
But basically, the bigger you want it, the more requests, the larger you go on each tier.
Yeah. And we'd want to optimize our workspaces. You kept them really simple.
Yeah.
Things like that. Yeah. Coming in okay, and I think that's good. Yep, somebody asked near the beginning, what is the name of the free open source web page that you presented that allows to communicate to services?
It's Swagger.
Swagger.
So yeah, I mean, Swagger is it's swagger.org, I think. You can just go there. And so I actually downloaded. You download the web app off swagger.org. It's a JavaScript library essentially.
Yep.
So it's a JavaScript library coupled up with the JSON that you produce, and the JavaScript library renders the JavaScript library renders the JSON into that nice design. So if you just Google Swagger, I'm not doing a very good job of Googling Swagger, but yeah, there it is, swagger.io, world's most powerful framework for APIs.
Great. Good. Yeah. So that's all the questions.
There's a few more at the end there.
Always work with the streaming features. Okay. Always work with the streaming features.
Streaming features. You need to use the data streaming service.
Right.
So basically, every HTTP request you make to FME must return something.
Yeah.
That's how it works. Yeah.
Yeah.
Okay.
Yeah, and really, I mean, a comment was made by Brian Timoney, which is a good one. I mean, development costs are huge.
Yeah.
Developers are hard to find, and good developers are hard to find. They're very pricey. They're a very valued resource, and so if you can offload this or make them more productive through something like this, the costs you save there are gonna dwarf it, almost anything.
So
yeah, so that's good. So thanks so much for joining us this morning, and thanks Stuart for putting all this together.
Yeah,
this has been great, and do reach out to us. We're on live chat at safe.com. If you think about a question now or later, we're always there, and we're obviously very excited about this. And yeah,
I'd love to help any of you if you have scenarios or you want help getting going. I've spent a lot of time in Gateway now, so I'm happy to help.
Yeah. So that's great. So I think with that we're good.
Yeah.
So thanks, Stuart. Yeah.